All right, today we tackle section 8.3. On the second part, today we're going to be solving, so again, our objective for this lesson was to be able to solve absolute value equations and inequalities, both graphically and algebraically. Okay, so we've already tackled the graphically part, so today we're going to deal with the algebraically part. Okay, so to solve absolute value equations algebraically, we need to remember that absolute value functions, the absolute value of x, can be written as a piecewise function. It's just equal to x, meaning it doesn't do anything for any x's that are greater than or equal to 0. But I need to take the opposite of x for any x's that are less than 0. Okay, so I need to take the negative of x, or the opposite of x, for anything that's less than 0. Okay, so if I put in an 8, for example, f of 8, absolute value of 8, since 8 is greater than or equal to 0, I don't need to do anything to it. It's just going to be 8. Whereas if I do f of negative 7, the absolute value of negative 7, well, that's less than or equal to 0. So I need the opposite of negative 7, which would be positive 7. Okay, so we have to remember that those absolute value functions can be written piecewise, which means that you have to solve them into pieces. So to be able to solve an equation like this, first step 1, first, I say isolate the absolute value. Get the absolute value thingy all by itself. So first, the absolute value is right there. Well, the absolute value has a plus 1 to it. So I'm going to subtract 1 from both sides. Again, there's my equal sign right there. So then my left-hand side just becomes the absolute value of 3x. So I got the absolute value all by itself. And then 7 minus 1 equals 6. So since this can be written as piecewise, meaning if this is positive, it's just going to equal just a 6. So basically, I solve this now in 2 separate steps. 3x equals 6, or the other half, that 3x inside of there could be a negative 6. Again, it could be x, it could be negative x, it could be 6, or it could equal negative 6. So the thing that it's equal to could either be the positive of that or the negative of that. And then I just solve it like we've been solving. I divide both sides by 3, x equals 2. Here, I divide both sides by 3, x equals negative 2. So my solution set for here is negative 2 or 2. Either one of those will work, and then it's always a good idea to come over here and check them both. The absolute value of 3 times 2 plus 1, does that equal 7? Question mark. 3 plus 2 is 6. The absolute value of 6 is 6. 6 plus 1 is 7. Yep, that one worked. What about the negative? 3 times negative 2 plus 1. Well, that's negative 6. The absolute value of negative 6 is 6 plus 1 does equal 7. So they both worked. Negative 2 or 2. So you do solve absolute values in 2 parts. Okay, so now this next one, again, we want to isolate that. So first step, first step, isolate the value, isolate the absolute value. Step 2, second step, set equal to itself and its opposite. And then our step 3 down here, what did we do? Third step, solve it. Very last step 4, check it. Okay, that's really what we did. So we isolated the absolute value. We set itself equal to itself and the opposite. That was the step right in here, set equal to itself and the opposite right there. Third, solve it. That was this stuff down here, was us solving it, and then check it. That's over there. Okay, so let's go ahead. Let's do another one. First, isolate the absolute value. So first, find the absolute value right there. Isolate it. So plus 1, we need to subtract 1 from both sides. Absolute value of 3x plus 1 minus 1 equals 0. So we isolated the absolute value. Set equal to itself and its opposite. So I set the 3x equal to 0, or 3x equals the opposite of 0. But what's the opposite of 0? 0. So this one is only going to have one solution. I only need to solve one side of it. 0 divided by 3 is 0, so 0 is my only solution. 0 is the only number that will work in here. Okay. All right, so now here's my last one. Again, isolate the absolute value. There's the absolute value right there. So right now I've got a plus 1. I'm going to figure out where my equal sign is, so I need to subtract 1 from both sides. So the absolute value of 3x equals -1. All right, so now step 2, set it equal to itself and its opposite. So 3x equals -1 or 3x equals 1. Divide both sides by 3. X equals -1/3 or x equals 1/3. Okay, so now at this point we check it. It's always the last thing we do. So the absolute value of 3 times -1/3 plus 1 equals 0. 3 times -1 is -1. The absolute value of -1. The absolute value of -1 is 1 plus 1. No, that didn't work. Nope, didn't work. So -1/3 doesn't work. All right, so what happened? Okay, here's a bit of a red flag. I could have told you right here that there's no solution right here. An absolute value cannot equal a negative. An absolute value cannot equal a negative. Because when I take the absolute value of whatever's inside here, it's going to give me a positive. So I could tell right here that there was going to be no solution. But even if you don't catch that and you keep solving it, if you check your work, you'll find it. So for sure, always check your work because sometimes there will be no solution. Okay. So in this case, there is, so if it says to solve, I would have to write, there's no solution. Neither of these will actually work because of the way the absolute values work. Okay. All right. Okay, our last bit is we're going to solve absolute value inequalities. Absolute value inequalities can be divided into 2 cases. A less than case, so here, this is our less than case. If my absolute value is less than a number, okay, if it's less than a number, that's going to be an and statement. I'm going to get a set of numbers and it's going to be an and statement. I need to put it between those 2 numbers. It's going to be an and statement. Basically, if it's less than, whatever is inside this absolute value, this ax plus b, whatever's inside of there, is going to have to be between c and its opposite if it's less than. So there's my c, and then over here is the opposite of c. Okay. Again, you still isolate the absolute value first, but then if it's a less than, you set it up this way. If it's a greater than, it's going to be everything from like this point on up and this point on down. It's going to be an or statement. So what's inside of that absolute value? That ax plus b is going to have to be greater than c or less than its opposite. Ax plus b is going to be less than negative c. Okay, so this is just one of those things that we're just going to either you memorize it, or I always like to revert to graphing if I'm not sure. Revert to graphing. Go back to the graphing method and look at them graphically if you're not sure. Oh, I didn't leave a whole lot of room for these 2. That's all right, we'll fit them. Okay, so this one, first you have to identify, well, first you have to isolate the variable, isolate the absolute value. In this first one, my absolute value is isolated. It's over here on one side already by itself. So, and then I look and it's a greater than. My absolute value is greater than. This is a greater than. Since it's a greater than, I know that what's inside this absolute value, this x minus 8, has to be greater than 5, or x minus 8 has to be less than the opposite, negative 5. And then I just solve them as 2 separate inequalities. So here I'd add 8 to both sides. X is greater than 13. Or here, add 8 to both sides. X is less than 3. So if I was to graph my solution set here, My solution set would be anything larger than 13. So 13, open dot on up, open dot because I'm not equal to, and then everything from 3 on down, open dot this way. Okay, so again, check your work. Pick a number up here, I don't know, 20. Put it in there and see. The absolute value of 20 minus 8, is that greater than 5? 20 minus 8 is 12. The absolute value of 12 is greater than 5. Pick a number down here, 0. The absolute value of 0 minus 8 is negative 8. The absolute value is negative 8. That's greater than 5. Yep, that one worked as well. So pick numbers in those intervals just to make sure. Okay, this next one, I have to isolate the absolute value first. My absolute value is right here, but I've got a plus 1, so I need to subtract 1 from both sides. So I have the absolute value of x minus 3 less than or equal to 4. This is now a less than problem. Since it's a less than problem, I'm going to be looking at in between numbers. So this x minus 3 has to be in between 4 and the opposite of 4, negative 4. And then now we can solve these like we did as a three-sided equation. I want to get this x in the middle by itself. So I'm going to add 3 to all three equations. Negative 4 plus 3 is negative 1. X equal to 7. So to graph this solution, it'd be any numbers in between negative 1 and 7. And I would use closed dots because these are both equal to. So closed dots from negative 1 into 7. And again, now I'm going to check my work. I'm going to pick a number in between negative 1 and 7. I don't know, how about 0? And let's try it. Absolute value of 0 minus 3 plus 1. Is that less than or equal to 5? 0 minus 3 is negative 3. Absolute value of negative 3 is 3. Plus 1 is 4. Yep, that's less than or equal to 5. It worked. Pick a number outside of that interval, like pick 10. 10 won't work. Down here, I could pick negative 15. Yeah, that won't work either. Only the numbers in between negative 1 and 7 will work.